Okay, when we get to ones like number 3, we have to find the measurement of every angle and every side. And in this case, we're going to need to figure out what this whole thing looks like. So let's start by drawing a triangle. It doesn't have to be perfect. Most of the ones that I draw end up looking like equilateral triangles anyway, when they may not even be that way. I'm going to try to draw this one pretty accurately. Knowing that these two are very small acute angles, I know I need 2 very small acute angles, which means the third one has to be pretty wide. So it's going to be obtuse. There we go. The picture does not have to be perfect. Again, if you want to draw 3 60-degree angles, make it look equilateral, I'm fine with that as long as we label things correctly. So we'll call this one C, we'll call this one B, and we'll call this one A. And you're probably wondering, why in the world did you call them that? Well, thanks for asking. We needed these two to be the small angles. If we're going to go on this, on the assumption that it's relatively to scale, then we need these two to be the small angles, which means that this is 18 degrees, this is 13 degrees, and little a, don't put it here, that's big A, obviously. Little a is across from big A, and so it is 10. 10 what? I don't know. Centimeters, feet, who knows? So we need to find the length of everything that is missing. Every missing angle, every missing side. So let's start labeling the things that are missing. What we do know is little a. What we don't know is big A. We're missing that. For what it matters, we're also missing this side, and it's across from big C, so it must be little c. This side is across from big B, so it must be little b. And we're going to find the measurement of everything that is missing. Let's start with the easiest. Honestly, best place to start, if you know 2 of the angles, then you almost automatically know the third one. When I add these 2 angles together, I get 31. These 2 angles together add to be 31 degrees. In any triangle, I'm not even going to write this down, but I'm going to say it. In any flat triangle, there are exceptions when you get into higher mathematics, but in any flat triangle on a plane, then flat surface, then the 3 angles together add up to be 180 degrees. We've already established that, so 180 minus both of these together, which is 31, is going to give us 149. So we automatically have found the third angle. It required very little effort, 149 degrees right there. Okay, let's find everything else that's missing. In order to find what is missing, using the law of sines, we need any one pair of angle and side that are opposite each other. Let me translate that for you. Since I know that this one is 149, and that's an angle, then I should know this side across from it as well. And I do. And because I do, I'm going to use those. So let's just write it down. The sine of big A over little a is going to equal, and it doesn't matter what we find now. It does not matter. I'm going to go alphabetical because I feel like it. So let's find B next. So sine of big B over little b. And we're going to fill in what we know and find what we don't know. I do know big A, it's 149. So the sine of 149 over little a, which is 10, equals the sine of big B, which is 13 degrees, let's put that in there, over little b, which is, well, don't know, little b. In the process of cross multiplying, we'll have 10 times the sine of 13. Let's come down here and write that. So we have 10 sine 13 degrees equals, and then b times the sine of 148. So b sine 149, I'm sorry. I said 148, but it's really 149. When we solve for this, for b, we're going to have to divide by the sine of 149. Those cancel, the whole thing cancels. Sine of 149. Now, I don't know what that is, you don't know what that is, but the calculator will tell us. So 10 times the sine of 13 divided by sine of 149. Okay. Let's round to the nearest tenth. I'm sorry, hundredth. Let's use 2 decimal places for side lengths. So 4.37, whatever units they are, feet, meters, miles, don't know. There we go, we just found B. Lucky us. 4.37. Okay, let's find the measure of angle. Sorry, not measure of angle. Let's find the length of side C. Since I'm looking for C, excuse me. Okay, ignore that bell. Since I'm looking for the length of side C, then whatever I do better involve the letter C. Okay, I'm going to say that again. I'm looking for C, so I know I better be using this lowercase c, and I better be using uppercase C, which is really 18. Now, in the process of finding it, I know I need those two. And I need any other pair that I have of angle and side. I could also go this route. I could use 13 with that one, or I could use 149 with that one. Either one. I'm going to use what I was given to start with. This will all make sense in a minute, I really hope. The sine of anything I have paired with its opposite side of any angle I know with its opposite side that I also know. I know big A, I know little a. Again, I could have started it this way. I could have started with that because now I know big B and I know little b. This is an estimate because it was rounded off, but I could have done it that way. I'm going to go back to what I had originally. Sine of big A over little a equals, looking for C, better use C, sine of big C over little c. Let's fill some stuff in. I know big C is 18, sine of 18 over what I don't know, little c, sine of 149 over 10. Hey, can I give you a shortcut? Of course I can. Actually, it's not a shortcut. It's just in our head doing a couple steps to get down to here. I'd like to think that we're at this point now. Cross multiplying will give me 10 times the sine of 18. Let's write it down. 10 sine 18. And that would equal C times the sine of 148. In the process of solving what I just had in my head, I would have to divide by the sine of 149. I did it again, didn't I? I said 148 when it's really 149. It's the second time that's happened. Anyway, there we go. That's your answer, whatever that is. What I just did was skip a step. I skipped this little step right here. It's going to take us straight down to there. So 10 times the sine of 18 divided by the sine of 149. I got a number that is painfully close to 6. Normally I round it to 2 decimal places, but the number I got is that. 5.99988, that's 6. Let's just be realistic, that's 6. So C equals 6. There we go. And that's number 3. We found everything. We had to use the law of sines more than once, but that's okay. Now, we're about to go through number 4. And it's not going to be very much different. Actually, let me erase as I talk. It's not going to be very much different because it's set up pretty much the same, however, the letters are different. See, now we have F and N, and we don't even have a third letter in there at all. But that's okay. We'll make one up. You don't have to use A, B, and C. When we get to the next lesson on the law of cosines, you don't have to use A, B, and C there either. We're going to, but you don't have to. So here goes. Number 4. Angle F is 31 degrees. Measure of the length of N is 21, whatever that is, 21 feet, meters, good grief, I don't know. 43 degrees. There we go. We have big F, little n, and big N. So we have an F and an N, and we don't have a third letter. I don't care what letter you use. It doesn't matter. I'm going to use A because it spells fan. I don't care how you draw it either. It doesn't matter. You can make it obtuse, acute, right? You can draw it all kinds of ways as long as you label it correctly. If this is F, big F, then that angle in the corner better be 31 degrees. if this is in, and it doesn't matter, but if this is in, then this angle in the corner better be 43 degrees. And little n is across from big N, so if that's big N, that's little n. I've residue from my last triangle floating around here. Ghost of problems past. There we go. That's little n. That's little f. And then, again, we don't have a third letter. Make one up. It doesn't matter. My name starts with an A. I'm going to use an A, and I'm going to use a little a there. And I have to find everything I'm missing. This is almost exactly like the last problem, so I'm going to go a little faster on this one. So, let's see. We start with two angles. We need the third one. Super duper easy. These two together add to be 74. 180 minus 74 is 106. There we go. Obviously, this is not drawn to scale because that looks acute and that is an obtuse angle. But yeah, let's see. I'm going to double check because I didn't use a calculator. Yeah, I'm right. Okay, let's start with what we know. I didn't label something that I should have. This is 21. Let's stop. Take an assessment of what I have. And when I'm looking for what I have, I'm actually looking to see what pair, angle and opposite side, that I know, and that's going to be a great starting place. Angle and opposite side. I know an angle, but I don't have its opposite side. Dang it. I know an angle, but I don't have its opposite side. I know an angle, and I do have its opposite side. So in whatever I'm about to do, I know it better involve these numbers right here. That's the whole point of the law of sines. It better involve the 43 and the 21. It has to, because these are opposite each other. So let's go alphabetical. I'm going to start with A. I'm going to start by finding A right here. And in the process of doing that, I have to use what I know. I have to use the complete pair that I have, the angle and the side. So the sine of n over little n equals the sine of, looking for A because I arbitrarily picked it. I said fixed it. There we go. That's what it's going to be. Now, Mr. Reader, I thought the formula had D's and C's. You can put N's in there if you want to. Perfectly okay. Okay, here we go. Sine of 43 over 21 equals sine of 106 degrees over, don't know, A. I'm going to cross multiply and divide. I'm going to do it all in one step. I hope it doesn't confuse you. 21 times that. 21 sine 106. A times the sine of 43. In the process of solving, I'm going to have to divide by the sine of 43. For some reason, I feel the need to write this one out one more time. I didn't on the last problem, but I'm going to do it here. A times the sine of 43. I was going to skip a step in my head. Not a good idea. In the process of solving, since I'm looking for A, I will divide by the sine of 43. Cancel. There we go. Whatever that is, that's A. We're about to do the exact same process to find F. So first, let's grab a calculator. We'll type that in. We'll round it to 2 decimal places since I'm looking for the measurement of a side. 21 sine 106 divided by sine 43. I got 2960. 29.60, leave the 0 off. Okay. 29.6, there we go. Now let's find F. Let's find it. We'll use red. In the process of finding F, I need an angle and a side that's across from it. So again, sine of capital N over little n equals sine of, well, looking for F, let's use F. 31, oops, should have used the letter F. I haven't quite set it up yet. There we go. Fill the numbers in, let's go from here. I'm going to go quick. Sine 43 over 21 equals sine of 31 over that I don't know, lowercase f. We are going to cross multiply 21 times the sine of 31 that would normally be equal to f times this, but we're going to have to divide by that to solve it. That was an annoying sound, wasn't it? Sounded like this. Yeah, that was annoying. All right, let's divide that in the calculator. Well, let's figure that out in the calculator. 21 sine 31 divided by sine 43. There we go. Got it. Lowercase f. 15.86. Okay, in the next video we're going to tackle the next problem, which of course will be number 5, and number 6 at the same time actually, because they deal with the same picture. And it shows you how practical some of the stuff really is in the way that people use trigonometry, law of sines, and eventually law of cosines to figure out distances. So, alright, next video is going to contain that.